Find the diameter and the area of the circle. Locate the center. Join line OD, line OC, line OB, line OA, line AC, line AB and line CD. Each equals r, the radius of the circle. Also, label point E and G. Angle DEG equals to 90 degrees. The reason is that line BC and line AD intersect at 90 degrees. Let labeled angle COD equals 2 times theta, and labeled angle AOC equals 2 times beta. But labeled angle ABC equals beta, which equals to labeled angle ABC. It is because the angle at center is twice that at the circumference of the circle. It implies that angle ECG equals 90 degrees minus beta minus in bracket 90 degrees minus theta, which equals theta minus beta. Since BOC is an isosceles triangle, angle BCD equals angle CBO, which equals to theta minus beta. This implies that angle BOC equals 180 degrees minus in bracket 2 times theta minus 2 times beta. Hence, angle AOB equals angle BOC minus angle AOC, which equals 180 degrees minus 2 times theta. From triangle COD, length of an arc CD equals the product of 2 times theta and 2 times pi times r, all divided by 360 degrees, which equals to 6. We call it equation 1. From triangle AOB, length of an arc AB equals the product of 180 degrees minus 2 times theta and 2 times pi times r, all divided by 360 degrees, which equals to 4. We call it equation 2. Divide equation 1 by equation 2. We have that the product of 2 times theta divided by 360 degrees and 180 degrees minus theta divided by 360 degrees equals 6 divided by 4, which equals to half of 3. Simplify to have the equation shown on the screen. Then, cross-multiply. 2 times the product of 2 and theta equals 3 times 180 degrees minus theta. Open brackets. Four times theta equals 540 degrees minus 6 times theta. Combine like terms. We have that the sum of 4 times theta and 6 times theta equals 540 degrees. This implies that 10 times theta equals 540 degrees. Divide the equation by 10. Theta equals 540 degrees divided by 10, which equals 54 degrees. Substitute into equation 1. Two times the product of 54 degrees and 2 times pi times r, divided by 360 degrees equals 6. Simplify and we have that 3 times the product of pi and r divided by 5 equals 6. Solve for r. We obtained that r equals 10 divided by pi in centimeters. After simplification of substituted value, it follows that 2 times r equals the diameter of the circle, which equals to 20 divided by pi in centimeters, as shown on the screen. Solution to question I. The area of the circle equals the product of pi and r, which equals to 100 divided by pi in square centimeters. After simplification of substituted value, or 31.83 square centimeters to 2 decimal places. Find the value of the green area. Label points A, B, C, D, E, Q, H and G. Join line A or C and let line B, CB equals to X. But line A or D equals line B, G, which equals to the sum of X and 2. It is because the opposite side lengths of a rectangle are equal. And line AB equals 8. Line CD equals line D, E minus line C, E, which equals 4. After simplification of substituted values. Since line D equals line A, H. This is because opposite side lengths of a rectangle are equal. Consider right triangle ABC. Use Pythagoras theorem. The square of line A equals the sum of the square line AB and the square of line B, C, which equals the sum of the square of 8 and the square of X. It implies that the square of line AC equals the sum of 64 and the square fx. We call it equation 1. From right triangle ACD. Use Pythagoras theorem. The square of line AC equals the square of line CD and the square of line AD, which equals the sum of the square of 4 and the square of the sum of X and 2. We obtained equation 2 for the square of line A or C. Equate equation 1 and equation 2. The sum of 64 and the square of X equals the sum of 16 and the square of the sum of X and 2. Expand bracket. The sum of 64 and the square of X equals the sum of 16 and the square of X plus 4 times X plus 4. Combine like terms. It follows that 64 minus 16 minus 4 equals 4 times X. Simplify and we have that 4 times X equals 44. Divide both sides of the equation by 4. X equals 44 divided by 4, which equals to 11 in units. Hence, area of triangle ABC equals half the product of line AB and line B, C, which equals half the product of 8 and X. The result is equals to 44 in square units. After simplification of substituted values. Also, area of triangle ABCD equals half the product of line AD and line CD, which equals half the product of 4 and the sum of 11 and 2. The result equals 26 in square units. The green area equals the sum of the area of trapezium CGQ, a minus area of triangle ABC. And the area of trapezium ACE minus area of triangle ACD, which equals half the sum of line CG and line AQ times line GQ minus 44, which is the area of triangle ABC, and half the sum of line CE and line AH times line HE minus 26, which is the area of triangle ACD, as shown on the screen. Substitute values and we have that the green area equals half the product of 8 and the sum of 12 and 13 minus 44 plus half the product of 13 and the sum of 4 and 8 minus 26. The result is equals to 68 in square units. Therefore, the green area equals 68 in square units. What is the perimeter of the red area? Label points B, O, C, D, E, and G. Join the centers of the circles. This implies that line OB equals the sum of 1 and the square root of 2 plus the sum of 1 and the square root of 2, which equals the sum of 2 and 2 times the square root of 2. Also, line BC equals line OC, which equals the sum of 2 and the square root of 2, as shown on the screen. BOC is an isosceles triangle, using cosine rule. The square of line OB equals the sum of the square of line BC and the square of line OC minus 2 times the product of line BC and line OC times cosine C. Substitute values and we have that the square of the sum of 2 and 2 times the square root of 2 equals 2 times the product the square of the sum of 2 and 2 times the square root of 2 and 1 minus cosine C. Make 1 minus cosine C the subject of the formula. We obtained an equation as shown on the screen. Combine like terms and we have that cosine C equals 1 minus 1, which equals to 0. Take the cosine inverse of the equation. Angle C equals cosine inverse of 0, which equals to 90 degrees. Hence, BOC is a 45 degrees right triangle, which is also an isosceles triangle. By using the formula for length of an arc of a sector, that is 2 times the product of θ and π times r, all divided by 360 degrees. We have that length of curve DG equals 1/4 the product of π and the sum of 1 and the square root of 2, which equals to the length of curve EG. After simplification of substituted values, it is because circles with center B and O are congruent circles as seen in the figure shown on the screen. Length DE equals 90 degrees times the product of 2 and pi times 1. All divided by 360 degrees, which equals half of pi. The required perimeter of red area equals the sum of 2 times length DG and length DE, which equals 1/4 of the sum of 2 times 1 plus the square root of 2 and half of pi. The result is equals half the product of pi and the sum of 2 and the square root of 2 in units. After simplification of substituted values. What is the length, x? Label points A, B, C, D and E. Join line OE. Line O, A equals line OD, which equals to 9 units, as shown on the screen. By Pythagoras' theorem, the square of line BO equals the square of line OE minus the square of line BE, which equals the square of 9 minus the square of x. Take the square root of the equation. We have that line BO equals the square root of 81 minus the square of x. Label points F and Q. Join line C, Q. Line E, F equals line C, F, which equals to line F, Q. Consider triangle CBE. By Pythagoras' theorem, the square of line CE equals the sum of 106 and 10 times the square root of 81 minus the square of x, as shown on the screen. Take the square root of the equation. It implies that line CE equals the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Divide line CE by 2. We have that half of line CE equals to half of the square root of the sum of 106 and 10 times the square root of 81 minus the square of x, which is equals to line labeled CF. Also, the result is equals to line labeled EF. Since QFC is a 45 degrees right triangle, angle cube CF equals angle C cube F, which equals to 45 degrees. By Pythagoras' theorem, the square of line CQ equals the sum of the square of line CF and the square of line FQ. Substitute values and we obtained an equation for the square of line CQ, as shown on the screen. Take the square root of the equation. It follows that line CQ equals the square root of the sum of 53 and 5 times the square root of 81 minus the square of x. Consider triangle CEB. Let labeled angle ECB equals theta. By trigonometric identity, cosine theta equals the sum of 5 and the square root of 81 minus the square of x, all divided by the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Also, sin theta equals to x divided by the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Join line OQ. From triangle COQ. Use cosine rule. The square of line QO equals the sum of the square of line CQ and the square of line CO minus 2 times the product of line CQ and line CD times cosine theta plus 45 degrees. Substitute values. We obtained a new equation as shown on the screen. We call it equation 2. By trigonometric identity. Cosine theta plus 45 degrees equals the product of cosine theta and cosine 45 degrees minus the product of sine theta and sine 45 degrees. Substitute values of cosine theta and sine theta. Already, we know that sine 45 degrees equals cosine 45 degrees, which is equals to 1 divided by the square root of 2. Hence, we have that cosine theta plus 45 degrees equals the value shown on the screen. Simplify. Cosine theta plus 45 degrees equals 5 minus x plus the square root of 81 minus the square of x. All divided by the product of the square root of 2 and the square root of the sum of 106 and 10 times the square root of 81 minus the square of x. Substitute the result into equation 2. We obtained a new equation as shown on the screen. Then, simplify the right-hand side of this new equation by performing basic arithmetic and algebraic processes. We have that 81 equals the sum of 53 and 5 times the square root of 81 minus the square of x plus 25 minus in bracket, the sum of negative 5 times x and 5 times the square root of 81 minus the square of x plus 25, as shown on the screen. Open bracket, so that we can cancel equal terms with opposite signs. After simplification, we have that 81 equals the sum of 53 and 5 times x. Solve for x, divide the equation by 5. Therefore, x equals 28 divided by 5 in units or 5.6 units.